I'm gonna start here. I have a little sheet that just says that I read the syllabus and shown it to a parent. So I'd like you to take this home, bring it back. You can hand it back in person, or you can submit it on into the OneNote. Either is okay, but try to get that taken care of at some point this week. Sorry about that. Fucking at it. I think I shorted this.
Mr. Cook, can I have one?
Yeah, did I short you guys one?
Yeah, just one.
Okay. Thanks. This one down. Okay. Again, not a huge rush on that, end of the week, whatever. If you forget, you can submit it at home just into the OneNote or whatever, that's fine. Digital is okay, no rush.
Are we getting points for this?
Yeah, it's a homework assignment, it's your first homework assignment, it's a 5-pointer.
How
So-
much are most homework assignments?
5 or 10, kind of depends on if it's a Delta math or if it's a paper. So plan for today. We're gonna rehash a little bit of what we did last time, talk about through a couple more example problems. I'm gonna give you guys your first classwork assignment today to complete in class. We'll take a half an hour or so to do that, it's 5 problems, so not a ton. And then we'll continue on after that.
Can I borrow a copy of it? Sure.
Yeah, you can grab that one off the desk. Will you leave me some sort of collateral though, like an ID or something like that? That'll do.
Right here?
Yep, you can take that one. Okay. So last time we talked about, like using a right triangle and the side lengths to write our ratios for sine, cosine, tangent, etc., right? Yes, you guys remember that?
Yeah.
Yeah, but we don't need it right yet, so
Okay.
just sit tight. So we had SOHCAHTOA basically saying that in a right triangle with this angle theta, we have opposite, we have adjacent, we have hypotenuse. So we can say that like sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? And we talked about how those labels of opposite and adjacent are always relative to the angle that we're looking at, right? So if we're looking at the other acute angle inside of our right triangle, opposite and adjacent flip, but hypotenuse stays the same. Everybody's okay with this? So if you notice though, if I have a triangle with, it has 3 labels on it, and I'm gonna make pairs, there's actually 6 ways to pair up those side lengths, right? Like why isn't, hypotenuse over opposite something? Guess what? It is. Yeah, it is. So there are 3 other trig operations . So for example, we have cosecant, which we abbreviate as CSC, which is hypotenuse over opposite.
Nope, you're all good, thank you.
We have secant, which we abbreviate as SEC, which is adjacent over hypotenuse. And then we have cotangent, which we abbreviate as COT, which is adjacent over opposite. So in this course, we will be talking about, instead of there being 3 trig operations, there's going to be 6. So if I look at the formulas for sine and cosecant, cosine and secant, and tangent and cotangent, what do you notice about their formulas? They're what?
Inverse.
Close. That's not quite the right word. You want reciprocal, right? Yes. So we call these guys the reciprocal functions. Oops. Because they are, cosecant is the reciprocal of sine. Secant is a reciprocal of cosine, and cotangent is a reciprocal of tangent. Yes, sir.
So doesn't that mean that cosecant would be equal to 1 over sine?
Yes. Yes. 100%. So you could make that further statement. Yes, Max.
Why then is cosine the exact same thing as secant? Adjacent over?
Oh, that's a typo. That's a big one, though. Thank you for pointing that out. Let's grab a different color so we can see that I made an edit here. Woo! Yeah. Make sure you guys fix that one. Yikeruskis. When you write down formulas, the last thing you want to do is make a typo there. So again, I did that one in green so you can see what I changed as the mistake. Whoopsie daisy. That's a big one. But again, is this really any more difficult than SOHCAHTOA stuff was, right? We just have some new definitions, but like whatever, it's still doing opposite and adjacent hypotenuse. If I can do it for sine, cosine, tangent, I can do it for these ones. I just have to remember the formulas. But do you have to memorize the formulas for a test or a quiz? No, what can you do with them?
Write them on your sheet.
You write them on your note sheet, right? So like, I don't have to memorize this. You probably will, because you'll use them enough to where like, okay, I remember this, but like, you don't have to have it stone cold memorized. You can be like, okay, I think I remember. Let me check. Yep. Okay, I got it. So far, so good. All right. Let's do a example problem. So this direction says we're going to write the other 5 trig ratios. So given that sine theta is 2/3.
And then the tricky one that we talked about is
So we're going to need to write cosine, tangent, cosecant, secant, and cotangent. Those are the other 5 that we're talking about. So the best way to do a problem like this is I want to first draw myself a picture. So I'm going to draw myself, a right triangle. I'm going to label one of the acute angles as my theta. And then because this trig function I'm given is sine, what is sine again?
Opposite over.
Opposite over hypotenuse, right? So I know that the opposite side should be 2, and the hypotenuse should be 3. Okay, well, that's the hypotenuse. That's the longest side. It's across from the 90-degree angle. And the opposite side to angle theta is the side across from it. That's going to be the 2. Everybody okay here? Feel good about how I've labeled things? We still have a third side to find. How am I going to find that third side?
Pythagorean theorem.
Pythagorean theorem, yes, sir. So remember the Pythagorean theorem. Says for a right triangle with sides A, B, and C, where A and B are the legs and C is the hypotenuse, that A squared plus B squared equals C squared. Right? We have to make sure that the A and B are the legs of the triangle and the C is the hypotenuse for the formula. So here I can say, let's just call this side X for the sake of our giving it a name. So we can say 2 squared plus X squared is equal to 3 squared. Does everybody feel good about the algebra setup so far that I'm doing, right? I need to find this third side before I can start filling in the ratios because I don't know what the adjacent side is right yet, right? We know that this one was opposite. We know this one is hypotenuse. And we know this guy is adjacent, but we don't know the value for it to put into the formula. So I have to find that before I start filling out my formulas. So a couple of algebra questions I'm going to ask. We have an algebra equation. What's the first thing I should do to solve this? Carter?
Since the 2 and 3 are squared, can you just move from 2 over to the 3 squared?
So you can't subtract 2 squared from 3 squared until you've done the exponent.
Okay, so do the exponent first, maybe?
Yes. That should be what we want to do first. So remember, when we talk about the order of operations, you know, exponents come before addition and subtraction, so you can't do the subtracting before you've done the exponent. We good? Okay. But now that we've done this, we can certainly do that. But are you good with that algebraic step? I'll scoot this up a little bit. I see people craning their necks. What happens next? What do we do next? Yes, sir.
Square root.
Square root both sides. When we square root both sides of an equation, what do we have to make sure we include? Yes, the plus or minus. But remember, what is x really? What is this x we're solving for? Because it's not just a variable x, it represents something.
Length.
Represents a length. So what does that tell me about the plus or minus? Just the plus, right? So I'm going to go back up to my picture and I'm going to just write in square root 5 where the x is. Is everybody good? Okay. Now that I have all 3 side lengths of my triangle, I'm ready to fill in my values for cosine, tangent, cosecant, secant, and cotangent. So cosine theta is adjacent over hypotenuse. That should be square root 5 over 3. Tangent is opposite over adjacent. That should be 2 over square root 5. What do you notice here about that particular answer, Stephanie?
You can't have a square on the bottom, so you have to put square root of 5 and square root of 5 and multiply.
Yeah. That process again was called rationalizing the denominator. So we'll multiply the top and bottom of that fraction by square root 5. We can't multiply a number inside a radical with a number outside a radical, so we just stick them next to each other. But square root 5 times square root 5 is like square root 5 squared, and the square and square root cancel, leaving them just 5. Everybody okay? Now, we could continue filling in the formulas, but there's a little bit of an easier one. I don't even need to look at the triangle anymore to finish this problem. Why? Because all I have left are cosecant, secant, and cotangent. And these are just the reciprocals of sine, cosine, and tangent, right? So cosecant should be the reciprocal of sine, which is 3 over 2. So I could continue using the formulas, that's fine, but, oops, forgot my theta there. Let's just do that, right? That's even, I think, even quicker. Secant is the reciprocal of cosine. So I could write 3 over square root 5, right? Reciprocal just means I'm going to flip the fraction. Now, what do you notice there? Yeah, same problem we had with the tangent. That's square root 5 on the bottom. So we'll do that same rationalize the denominator trick. And then our last one is cotangent, which is the reciprocal of tangent. Pro tip here, let's not take the reciprocal of this. I want to take the reciprocal of this one. Why is this the better one to take?
Because you don't have to then flip up and have a radical on the bottom and do the whole multiplication thing. You can set a radical on the top.
Yes. Perfect, yeah. So Max says that if I flipped this one, that's going to move the radical to the bottom, and then I'm stuck rationalizing again. If I take this one and flip it, the radical goes to the top, no problems. Let's do that. So there's our answer, right? Again, confusing question when you first read it, right? It's like, what the heck am I supposed to do with that? Oh, I'm just supposed to draw a picture, do the Pythagorean theorem, and then use the formulas. That ain't bad. Not bad. Yeah? You guys feel okay? Okay. And then, so I want to extend those out. And then last time we did, we had we talked about this kind of problem.
Should I calculate it in degree mode or radian mode?
What is the angle?
Degree.
So the calculator should be degrees. Yes. So the unit on the problem will tell you the mode of your calculator, right? So this problem is 36 degrees. Calculator should be in degree mode. I'll try very hard to make sure I put degree signs everywhere there's supposed to be a degree sign. I'm usually pretty good on that. Yep. We don't need to write this out though. Just kind of like hang. Yep, when I pass the stuff out to do the classwork, I'll happily make sure I get you a calculator. No worries. Yes, sir.
Okay, so I got a new calculator yesterday.
Awesome.
But, yeah, no, it's crazy. But, this one looks a lot different than the other one.
Okay. Oh, you have like a formal menu there on that? What type of calculator does this say?
It's the 84 Evo.
Okay. So you probably just want, you have a icon menu there.
I
Oh, well, you probably still just use the whole button. Right here. Yeah. All right. So this triangle, to solve the triangle, we're missing 3 parts, right? So I'm just going to name them, say, X, Y, and then Z. When I draw my Z's, I always put the bar in there because my Z and my number 2 look too hard to tell the difference for me, and I'm sure it'd be even worse for you guys, so I'm going to put the bar on the Z. All right. Which one of these 3 things is going to be the easiest thing to find to start? Stephanie?
Probably Z,
Yeah, why?
because you can just do 180 minus Is that 36?
Yes.
Sorry.
That's okay.
36 minus 90, and you'll find your Z.
Good. So you can do 180 minus 36 minus 90, or since it's a right triangle, we can just do 90 minus 36. So Z is 54. Relatively easy. Anybody with a question on that? Or you could have done 180 minus 90 minus 36. You'll get to the same spot. It's equivalent. Okay. Any difference between finding x or y next? No, they're both. It's going to be basically the same kind of idea. No, one is not any really more difficult than the other. So let's just say, well, let's look for x first. Sound good? Okay. So we're using this 36 degree. We know the 6, which is the opposite side relative to the 36. And we're looking for the x. That's the adjacent side. Which trig function do I want to use? Tangent. Why not cotangent?
I actually did use cotangent just because I think it's easier to have the x on bottom, but I guess your calculator.
That's the issue, right? There's no cotangent button on our calculator, so let's use tangent.
A quick question, why is side x adjacent? Is it because, since the 36 is given, we say that the 6 opposite?
Yes. Yeah, because we're looking at the 36-degree angle.
So
So-
opposite has given.
Right. For Z, x would be opposite, and 6 would be adjacent.
Yeah, but in this case it's given, so it's,
Doesn't, because it's given doesn't make it the opposite.
oh,
It's where it's at. The opposite is always across from the angle.
yeah, he's also an angle.
Right, but we're using the third. We said we don't know what. I mean, we could, but we chose to use 36. If you chose to use 54, then you could do it as x is the opposite and 6 is the adjacent.
Oh, it doesn't matter.
It doesn't matter. You could write either equation, but the parts have to be matched up, right? Yes,
Alan and I
Max.
have a question. What is the difference between inverse and reciprocal? And if reciprocal is just the same thing, can't you just do second tangent to get the cotangent?
So an inverse is a more general term than reciprocal. The inverse of multiplication is a reciprocal,
Okay.
but the inverse for a function is not a reciprocal.
Got it.
Right? Being an inverse of a function, like if a function takes x to y, the inverse needs to take y back to x.
Oh, you can't do that.
And
by-
that is not going to happen by, just like flipping the fraction.
Oh, yeah.
That's not going to take a ratio back to an angle measure, right? That's
Got it.
totally different.
Okay.
Is that,
Yes, that's
okay. Everybody's okay? All right, let's write this out. So we said we're going to have tan 36 equals opposite over adjacent, or Carter, you could have said tan 54 equals opposite over adjacent. Either of those is fine. You could write either one. It does not matter. It's personal preference. Since we know 54 degrees exactly, that's good. Either is fine. Everybody's okay? So from here it's algebra, right? So typically we think about making a proportion and doing the cross multiplication. Remember, cross multiplication is a solving technique, has nothing to do with multiplying fractions. So notice for this equation, we're done, right? The x is by itself. So there the algebra is a little bit simpler. I'm just going to round to 2 decimal places here. On this one, we'd have an additional algebraic step. We'd have to divide by tan 36, which is not the end of the world. And we get the exact same thing. Say approximate. We all okay? Okay. And then our last thing we need to find then is the y, right? What are my options here as how to solve for y? X.
Pythagorean theorem, or you could take one of the functions of one of the angles.
Good. So we could either use the Pythagorean theorem, because we have two sides, find the third, or I could do the same thing that I just did. Now, both are correct. Both are fine. Which one's going to be more accurate? Stephanie?
Probably doing like sine.
Using a ratio like we did before. Why?
Because instead of having to like just keep the square root, you can get like an exact number or like round it.
Not quite. There's a difference. Here's the difference. To do the Pythagorean theorem, we have to use this rounded answer. So we have two levels of rounding. If I do this, I can use 6 and the degree, both of which are given to me, I know exactly. That has only one layer of rounding to it, so it's going to be a slightly more accurate answer. For this class, will that make any bit of difference? No. If you're trying to land a rocket on the moon, will that make a difference?
Yeah.
Yes. So I just want to point out to you that like one method is superior to the other, but in the context of this course, it would not really matter, right? Okay. So let's grab a different color here. So again, I'm just going to use the 36. The 6 is the opposite. And then the y is the hypotenuse. So we will use, we got opposite, we got hypotenuse. Sine! Yeah, so I'll say sine 36 equals opposite over hypotenuse. Again, you could have used 54 and done cosine. You know, adjacent over hypotenuse, it's fine. I'm not going to write both equations down. Is everybody okay with me skipping that? Okay. It's also fine. It would be fine to do that, though. It's not wrong. We'll do our cross multiplication. We'll divide by our sine 36. You notice the algebra here is like exactly the same as the previous problem. And we get about 10.21. It's a messy one. What do you guys think? Okay?
Yeah.
This basically recaps what we did last time and tack a little bit on. Max, what's up?
Sorry for all the questions.
No, it's okay.
But would I ever be able to like use like the 90 degree and treat the hypotenuse as an opposite, or is that not?
So remember, SOHCAHTOA, our right triangle definitions of sine, cosine, and tangent work only for acute angles.
Oh, I didn't know that.
Yeah, so you can't use a 90 degree, you can't use an obtuse angle. It has to be an acute angle on a right
Okay,
triangle.
that makes-
Now, we're gonna get, in short order, expand that definition so we can use it on, say, a 90 degree angle or something, but it requires like a new way of defining what these things are and breaking them out of this triangle cage that we're currently living in. Okay, what do you guys think? It's all right?
Yeah.
Okay. I'm gonna pass out a sheet. We're gonna do our first classwork assignment. I'm gonna give you guys 30 minutes to work on this. It is 5 problems out of the textbook, so you'll need a copy of the textbook. Please wait till I pass these things out before you move. I don't know, I haven't counted how many I actually have sitting there, so if you need to share with somebody, that's fine. Can manage to share, it's only 5 problems, so you can even write them down, they're not really like very long problems either. But you can use your notes, you can use the textbook, this is like open. You can talk to your friends, that's fine, you can ask me questions, that's fine. You know, it's like Not a problem. I'd like you to see if you can do your 5 problems on this sheet. If you run over to the back, you can flip it to the back. But let's just try to like turn in this sheet back to me. Again, if you don't finish inside of this 30-minute window, you can come back and work on these during CT. That is okay. Any questions about what to do? Oh, I need to assign a group number to everybody, right? So we're just gonna do like, you guys are group 1, group 2, 3, 4. So that just tells you the 5 problems you're gonna work on, right? So that not everybody in the class working on the same set of problems. You have like a little bit of, you have some people that you can talk to that are doing the same stuff as you, but not everybody, and it spreads out a little bit the work and all that. I'm done talking. If you want a textbook, or if you need a textbook, go ahead and grab one. And we'll start a little, I'll start a little timer, and we'll see what we got left at the end.
You can share.
Oh, okay. Oh, you don't? Oh, it's fine.
Thanks for being patient. No, it's okay. It's okay. I get it.
Oh, page 335.
It's on the paper, right?
Yeah, it's on the paper.
I mean, I tried to give you everything you need on the sheet, right? Like,
Sorry, no, it's lost. My brain. My brain is broken. No, I'm in the right place. Don't worry about it.
oh, that's fun. You found somebody's
Oh, wait, no, we're not.
stuff here, huh?
Yeah, I know, like, it's
Cool, thanks.
Okay.
There's a proper notation when I'm writing sign.
Okay.
Like,
Keep it in the.
You can do either.
Or wait, what?
I like to put them in,
Yeah.
you know, like, probably in a problem like this, I'd go which way next.
Yeah, you will say that.
But you can put it in front, it's not long.
It's opposite over my back.
Can I borrow the
Yes, can I have your ID?
on Pythagorean theorem.
I think.
No, yeah. Wait. Oh, I have it.
So it's yeah. Okay. So it's really late. So.
Yeah.
So I did my metric equation that for sin, but then I think you find the x is equal to.
Okay. Still working. Oh, you're doing
So
so.
you just would be like on the Python.
I just.
You find x values and.
Yeah, I know. Well, I have it there. I was like, I forgot. Yes. Yes.
Wait, what? Hypotenuse. No, that's right.
Yeah.
Okay. Yeah.
Oh, fine.
So,